Good morning, everyone. I'm Anne Sebastian, and today I will be explaining 5 programs. That is, first one is decision making using decision tree. Second one will be AI agent, a simple AI agent for plant watering. Third one would be an expert system, a simple expert system. Fourth one would be DFS search using Python, and fifth one would be a DFS search. So let's move on to our program. First one would be the uh, decision using decision tree. For that, we need to import pandas as a PD. We have to import pandas, and from sklearn.model selection we have to import this train test split. And from sklearn.trees we have to import a decision tree classifier, plot trees. From sklearn.metrics we have to import accuracy store and a classification report. After that, we have to give data equal to pd.read CSV and our file location. This is the file that is stored in. My file was Seattle weather, that is stored in this location. After that, we have to give x equal to data dot drop of date, access of -1 dot ilog. That is, after dropping the date and the first line, we'll take all the line except the last one. So in the last column, all the line except the last column, first line would be exempt. After that, y is equal to date dot ilog of is 2, this -1. That means every line except the last line will be only the last line will be taken. After that, x underscore train, x test, y train, y test equal to train test, train test split of x, y test size equal to 0.3 and random state equal to 42. After that, we have to give model equal to decision tree classifier of random state equal to 42. Then we write model dot fit of x train, y train. After that, y pred equal to model dot predict of x test. Then we have to print the accuracy. Print accuracy. You can give accuracy is equal to accuracy score y test, y pred. After that, print classification report. In the next line, it will come classification report of y test and y print. After that, we have to import matplotlib, pyplot as a PLT. That is to draw the tree. Figure dot PLT dot figure equal to fixed size of 20, 10 to show the size. And plot tree model field equal to field names equal to x dot column, class name equal to str class for class in y dot unique function. With that PLT dot show, we have to run this. So let's try running this program. Second. Yeah. So let's go. It was supposed to come as a graph, but because of my file location error, there seems to be a small problem that can be fixed. After the problem is fixed, the output will be coming like it will show a graph. The graph would be like 1 second. I share the screen. The graph would be like something like this. It will come. So let's move on to our next program, that is AI agent for water planning. This is a simple AI agent everyone can understand. For that, so we move to the program. In that, soil is equal to int of input of soil moisture level. We are entering soil moisture level and we are entering like if it's raining or not. If soil moisture level is less than 40, and the weather is no, we have to water the plants. If not, soil moisture level is greater than 40, we can no watering is needed. Or if it is also raining, no watering is needed. After that, everything will be stored in this action. So we have to print agent decision is to action. Let's try running it. Okay. Soil moisture level 10. Is it raining? No. Water the plants. So let's try one more thing. Soil moisture level 40. Raining. No water is needed. So this program has been explained. So let's move on to the next program. That is expert system. In this expert system, we have to input fever, cough, headache, and fatigue. We have to answer if all answer all of these questions with yes or no. That is Y or N. After that, if we have fever, second. After that, if we have fever and a cough and headache, we have fever and cough, but no headache and fatigue. It will say we have flu. If we have fever and we only have fever, it will say it is a simple fever. And if we have only cough, it will say we have only simple cough. After that, we have headache and fatigue. It will say we have migraine. If it is only headache, it will say simple headache. If it only have fatigue, it will say just be tired. If we have all of them, it will say we have COVID-19. If not, it will say we are not sick. So let's try running the program. Do you have fever? We have cough. And you have headache. Why are you feeling tired? And okay, guys. Wait a minute. Okay, now I'll be explaining BFS search using Python. For that, we have to import DQ from collection. After that, we'll initialize a graph. You can put the graph anywhere you want. After that, we go def BFS of start. That is, here we'll print BFS transversal and BFS of A. That is, this is A. That we have, this is our goal node. So it will go here. This is our start node, and it will go from here. Visited equal to set function, that is to keep a track of the visited store nodes. After that, q is equal to dq of start. That is, we have to initialize q with starting node. While q, we have to start the loop. If node is equal to q dot pop left, that is, we will pop the leftmost element. If node is not in visited, it is not in this visited set, we have to print node comma end function. That is, we have to print the node, and after that we have to leave a space. Then we have to write visited dot add of node. That is, we'll add this node inside the visited set. After that, q dot extend of graph of node. That is, we'll add neighbor to the queue. After this, we can see the code running. Let's test it. Yeah, BFS transversal would be A, B, C, D, E, F. It will come like this because the graph is A, below that B and C. In B will become D, E, and in C will become F. D is empty and only E has F below that. So the BFS transversal will become like this. So let's move on to the next program, that is DFS transversal. Okay. For DFS transversal, we have to do the same. To write song. Okay. For the DFS transversal, such as DFS trans so BFS transversal, will import a DQ from collection. After that, we'll initialize a graph. After that, we'll write visited equal to set function to keep a track of the visited node. Then def of DFS node. If node not in visited, print a node comma end. That is to process the node. After that, visited dot add of node. We'll add the visited node inside the visited variable. For node in graph of node, DFS of neighbor. That is, if node if neighbor is in graph node, we'll again go DFS neighbor. So let's try running that program. The first transversal A, B, D, E, F, C for the same method. This is yeah. So this program has been successfully been proved. So thank you for watching and have a great day.